So question 5 is where we're at. They give us this diagram. Basically, we can infer that this distance right here is 1.6. This distance right here from 0 to 8 is going to be 8, and they're telling us that it's in meters. This distance right here, this whole thing is 10. That's also pretty important for us to know. Anything else that we can infer? No. All right. So they told us that Terry is standing. This is his eyes. This is his feet. So find the distance AB from Terry's eye line to the top of the flagpole. So here's Terry's eye line to the top of the flagpole. Okay. So this is the flagpole. So we want to find this distance right here. So for us to do that, I'm pretty sure that we can go ahead and create a right triangle right here. Okay, has nothing to do with D. It just happens to be on this line right there. But I know that since this is a rectangle, if this is 8, then this is 8 as well. Let's see if we can figure out what this is right here. Okay, so we know that this here is 1.6 and the whole thing is 10. So to figure out how much this is right here, 10 minus 1.6 is going to be 8.4. So this is 8.4 meters. So to figure out AB, I can use Pythagorean theorem here. So A squared, so for part A squared plus B squared equals C squared. So I'm going to do C squared, which is the length of AB, is equal to A squared, which is 8 plus 8.4 squared. So C is going to equal the square root of 8 squared plus 8.4 squared. So if you plug that into the calculator, you're going to get 11.6, okay? 11.6 meters. So that is the length of AB. All right. For part B now, it says find the angle of elevation from A to B. So from A to B, which is this angle right here. So we know that this is 8 and this here is 8.4. So we can use tangent because again, we have a right triangle. So the tangent of the angle that we have that we're looking for, I'm going to call this theta, is equal to opposite. So opposite OPP is 8.4 divided by adjacent, which is 8. So I'm going to do this in the calculator. Remember, to find the angle, I'm going to do second tan or inverse tan. And so then I'm going to get that theta is equal to 46.4, okay, degrees. And if you don't get these, please let me know, all right? The last part of this question, angle of elevation from A to D is 23 degrees, from A to D. So now we found out that the whole thing is 46.4, but we don't want that. We want from A to D. So let me just change the color. We want to know that right there. So we're looking for that. They're telling us that that angle of elevation is 23 degrees. So for part C, this here is 23 degrees. I know that our adjacent side is 8, and I'm looking for this right here for that height. So the tangent of 23 degrees is equal to opposite. We don't know that side, so I'm going to call that x. That's going to be x over 8, which is our adjacent side. So when you do that, you're going to figure out that x is about 3.40. Okay, and they want us to know the height of D from the ground. So this is already 1.6, and we just found out that this right here is 3.4. So from D, the height of D from the ground is going to be 3.40 plus the 1.6 that they gave us, and this is going to be about 5.00 meters. Okay, so that is A, B, and C. Okay. The last one, Voronoi diagram. I started this before I realized that the video was stopped, but anyway, midpoint is pretty straightforward. We have A, right, x1, y1, B, x2, y2, plug it into our midpoint formula. and you get 1.5 comma 1. Everybody that tried this got this right. All right, so let's talk about how they got line YZ, right? So YZ is right here, this line right here. So how did they get it? That line is the perpendicular bisector between points A and B, right? Do you see that? So if I take these 2 points right here and I find the perpendicular bisector between them, okay, um, that's going to be line YZ. So the first thing I want to do is I want to take these same points, the A and B, and I want to find the slope between them. Okay, so for the slope, y2 minus y1 over x2 minus x1. So I'm going to plug these same numbers in. So I'm going to start with my y's first. So 2 minus 0 over 3 minus 0, that's going to give me 2/3. Okay. This perpendicular bisector is going to have, right, I'm going to take this slope right here. This is my m, and I'm going to find the negative reciprocal of it. So the negative reciprocal of 2/3 is going to be negative 3 over 2, right? So that's the slope of my perpendicular bisector. That's the slope of my perpendicular bisector, okay? Um, so now what do I do with that, right? I'm going to use that formula, the y, uh, running out of space, but right over here, y minus y1 is equal to m parentheses x minus x1. So I found that my slope is going to be negative 3 over 2 x minus, and the point that I'm going to use is the midpoint, which is right here. So x minus, my x value here is 1.5, and my y value, so it's y minus, my y value here is 1. So y minus 1, okay? So I can take this and it says find the equation of the line. We want to take this and write this better. So we could just distribute this right here. So I get negative 3 over 2x plus, if I put that into the calculator, I get 2.25. So 2.25, and this is y minus 1. So I add 1 to both sides, and I get y is equal to negative 3 over 2x, and I'm going to add 1 to that, so that's going to be plus 3.25. And you could technically leave it like that. So that right there is going to be the answer for part B. Okay. Um, yeah, like I said, I'm running out of space, but let me just put an arrow here. So for the next one, for part C, the equation of the line through xz, they give us the formula, and they want us to find the coordinates of z. Okay. So this next one, the reason why it's worth 5 points is because this is more like a conceptual thing, okay? So here's line YZ, right? Here's line YZ, which we just found the the equation, right? This is the equation of line YZ. And they're giving us the equation for line XZ, okay? So do you see that where line YZ and where XZ meet, it's going to be at point Z, right? They share point Z with it, okay? Here's YZ, here's XZ, they intersect at point Z, okay? So what I'm going to do is I'm going to take this formula right here and this one right here, and I'm going to set them equal to each other, okay? So I have, to do that, let me get the y by itself. So add 2x to both sides, add 2x, and I get y is equal to 2x minus 1.5. And to find these coordinates, I'm going to set this right here equal to negative 3 over 2 x plus 3.25. And I'm going to see where these intersect, right? So y1, y2, see where they intersect. And you will see that they intersect where x is about 1.36. And if you take that number of 1.36 and you plug it into either of the two formulas, you're going to get that y is equal to 1.21. Okay, so that is the coordinates of z. Again, it's where xz and yz, where those two lines, where they meet. Okay. And that's how I got the answer to part C. So that was worth 5, right? And again, I'm running out of space here, so I'm gonna just go ahead and do my best to try to do the rest and have enough space for everything else. All right. So for part D, point X has coordinates. So now let me just kind of make this a little bit clearer. So point X, so this coordinate right here, they're telling us is going to be 2.5 comma 3.5. Okay. Find the length of XZ. So they're looking for this right here. They did tell us that this is a right triangle. So for us to be able to do that, we need something else, right? Let's look. So we're looking to see, we have this coordinate. Oh, we know what Z is, right? Z is right here. So we're looking to see the distance between those 2 points. Okay. So we're looking to find the length of xz. So we're going to find the distance. So distance formula is the square root. And you're going to go ahead and plug these numbers in. So it's going to be 3.5. So parentheses 3.5, which is this number right here, minus, and I'm going to do the y coordinate here, which is 1.21, right? All of that squared plus the 2.5 minus our 1.36 number that we got, da da da, squared, and you're going to hit enter in the calculator, and that is going to give you that the distance is about 2.56. 2.56. And again, you round at the end, and that's 2.56 units. So this we just found out was 2.56. Okay. All right, this is a lot. But this question was also worth like 18 points. Okay. All right, so now for a two-pointer, the length of xy, so they're giving us the length of xy, which is right here, to 3 significant figures is 4.47. 4.47, okay? And they're asking us for, find the area of the triangle, okay? So we could do that. So for the area of the triangle, again, this is a right triangle, okay? Right triangle. So area of the triangle is going to be 1/2 AB. So we have 1/2 A times B. So A we got, which is about 2.56. So I think the exact number is 2.5, a whole bunch of fives, dot, dot, dot. And then times our number that they gave us, which is 4.47. So you're going to take that, you're going to plug it into the calculator, and this is going to give us about 5.7. 5.7 is going to be the area. And they said giving your answer to 2 significant figures, okay? So 5.7, 2 significant figures. Good. And again, that was only worth 2 points, okay? City planners calculate that a car park needs to have 50 places for every 3 kilometers squared area served. Use your answer for part E. So use this answer to calculate how many car park spaces the car park at D needs. So for this, we're going to set up like a ratio. So 50 places for every 3 kilometers squared. And we're going to set that equal to, we don't know. And then on the bottom, we're going to use this number because it says use your answer from part E. So this is going to be about 5.7. And here you're just going to cross multiply. So 50 times 5.7 divided by 3. And x is going to be about 95 spaces. 95 spaces. All right, so we're going to have 95 spaces, car park spaces, that the car park at D needs. All right, last one. What assumptions are we making in F about the users of car park D? And in short, what assumption are we making? We're making an assumption that everyone that's looking for a parking space is going to choose to go to Park D, right? That's what we're making an assumption. But in reality, like there might be some like obstructions that we might have to kind of go around or something like that. So it might be because of traffic or road design to reach a different car park. That might be the assumption. So the assumption are we making is that all users, right, of the cars will want to park in D, right? In car park D. Um, but like traffic or congestion might prevent that. Prevent that. Okay. All right. Good job. Thank you. That was a very long test. All right. Bye bye. I hate buys. Later.